We are in section 7.2, similar polygons. Alright, so we're going to skip problem 1. Alright, problem 2. Are the polygons similar? If they are, write a similarity statement and give the scale factor. So first, to find out they're similar, let's compare the sides. So the angles on the sides. So problem 2, angle J is congruent to angle T because of their two angle marks. Angle K is congruent to angle U because they're both 90. Angle L is congruent to angle V, and angle M is congruent to angle W because of the angle marks. Alright, so the corresponding sides, JK corresponds to TU because it has two angle marks here in 90 degree, two angle marks here in a 90 degree. So JK to TU is 12 over 6, which is 2 over 1. KL corresponds to UV because there's a 90 degree there, 3 tick marks there, 90 degree, 3 angle marks there. So that's 24 over 16, that's 3 halves. Alright, so LM corresponds to VW because 3 angle marks, 1 angle mark. So it's going to be 24 over 14, which is 12 over 7. JM over TW, 6 over 6, which is just 1. So, since the corresponding sides are not proportional, the polygons are not similar. Unlike problem 2, because all the ratios are the same, therefore these polygons are similar. Because there are so many different ratios, there's 2, 3 halves, 12 or 7, 1, these aren't the same ratio, so they're not proportional. Alright, so try got it, letter A. Problem 2 is very similar to section 7.1. Alright, we want to know what is the value of x over here. So, we want to see what sides correspond to. Alright, so AB corresponds to EF, so it's 5 over y. And then BC corresponds to FG, which is 7.5 over x. So notice I do the big trapezoid, little trapezoid, little trapezoid. Then ED, so AD corresponds to ED, which is 9 over 6. So therefore, I'm going to do 7.5 over x equals 9 over 6. I'm going to cross multiply, and I get x equals 5. Now the book set theirs up the reverse, but we set ours up a little bit differently, but as you can see, we still get the same answer. Alright, so try to got it. They want to know what the value is of y. Alright, problem 4. Your class is making a rectangular poster for a rally. The poster's design is 6 inches high by 10 inches wide. The space allowed for the poster is 4 feet high and 8 feet wide. What are the dimensions of the largest poster that will fit in the space? So first, you want to find out if the height or width will fit the space first. So the height, so we go from inches to feet. So let's put the feet into inches first. So 4 feet equals 12 inches, 8 feet equals 96 inches. Alright, so I do the height divided by this height. 48 divided by 6 inches is 8, and then 96 divided by 10, do the width divided by width, is 9.6. Now, that means that the design can be enlarged at most 8 times, because 8 is a smaller number. So yeah, the width could be 9.6 inches, can be enlarged 9.6 inches, but the height can only be enlarged at most 8. So therefore, since the greatest height is 48 inches, we must find the width. So, therefore, if the width is, alright, so we'll do the poster's design 6 inches over the actual height equals, we don't know the actual height yet, but we do know this height. So then when we solve it, when we cross multiply, we get x equals 80. So therefore, our poster can be 48 inches high and 80 inches wide. And that's our answer. So, try the got it. Now the reason for number 3 we couldn't put it by, it wasn't 48 by 96, is because this is enlarged by 8. This is enlarged by 9.6. It must be the same number. So with 48 by 80, this was enlarged by 8, and this was enlarged by 8. Because we did 6 times 8, and we did 10 times 8. So the ratio must be the same in order for it to be similar, just like problem 1. Alright, and then number 5. The diagram shows a scale drawing of the Golden Gate Bridge in San Francisco. The distance between the 2 towers and the main span. What is the actual length of the main span of the bridge? So we see that 1 centimeter is 200 meters. So the length of the bridge is 6.4 centimeters. So we did the length of the drawing over the actual length, and when we solve for S, it's 1,280 meters. So try got it, letter A.